what is the by default duplex of router interface?
Sir, by default, sir, full duplex, sir.
Full duplex
No,
it is.
no. By default
Auto
configured mode, I am
negotiation it is.
yes, auto negotiation, right, on router. Let's say one router and one switch is connected together. Fine. On switch, I have configured duplex, half duplex. What will be the effect on router interface? Like router is directly connected with that interface. Getting my point? Switch, two
Yeah, so
switch are directly connected.
negotiation will happen, and according to that, it will set the duplex.
Set the duplex means half duplex.
Yeah, so like accordingly, so like whatever we set in the router one, so
Okay.
according to that, it set.
Then can these two devices work on half duplex? Let's say I need to transfer data, something from switch to router, or these devices is connected with end devices and end devices are trying to communicate. So can they communicate?
Yeah, it should communicate, right?
Okay. What is difference between half duplex and full duplex?
Like in half duplex, like it is able to send the data like from source to destination and destination to source, but at a time it will be one sided. And in the case of full duplexes, we can send source to destination and destination to source as well.
Hmm. Okay, so means sender can send the data as well as receive the data, but not at the same instant of time. That is half duplex. And if device can perform both sending and receiving at the same time, this is full duplex. Right, Prem?
Yes, yes, correct.
Okay. Yes, guys, exactly right. And simplex is one-way communication. Simplex is one-way communication. Means a sender device can only send the data, receiver device can only receive the data. Like your television is receiver device, right? You never put something, send something from your television to somewhere. It is used to receive the data only. So this is as as a receiver device. Like that, if sender can only send the data and receiver can only receive the data, that type of communication is simplex. That type of communication is simplex. Am I right, guys?
Yes, Ajay.
Yes, yes.
Yes, sir.
Okay. After
Yes, sir.
that, half duplex is a sender device. Example of simplex can be what? Television. Anything else?
Radio, radio,
Radio.
radio.
Exactly. Which is used as a end. Oh, 1 second. Okay. And half duplex. Half duplex is two-way communication but not at the same instant of time. Two-way means a device can send the data as well as receive the data as well, but it cannot do both sending and receiving at the same time. That type of device is called half duplex. Device means interface of device, means NIC card. Mode of NIC card is what? A port can only receive the data, or port can send the data only, or port can do both.
So
Or
can we give the example of? Can we consider the like walkie-talkie is the example for half duplex?
yeah,
Yes,
yeah,
exactly. Yeah.
yeah, yeah,
Walkie-talkie.
half duplex. and
Walkie-talkie.
Yeah.
and there are some devices also who works on this duplex. There's some application like Bluetooth. From Bluetooth you can send as well as receive, right? But at a time, either you can send or either you can receive. You cannot do both things. So Bluetooth is one kind of half duplex connection. Getting my point? Is it correct example, Prem?
Yeah, that is also
Okay.
correct.
And then full duplex. Duplex means two-way communication at the same time. At the same time, a sender port can send the data as well as receive the data. Means if we have bandwidth of a port is, let's say, 1000 megabyte per second. This is bandwidth of one port. So it can send the data equal to bandwidth and it can receive the data equal to bandwidth at the same time. Okay. And if you will see practical, so here let me share my computer screen and we can perform on a small lab in Packet Tracer. Is my screen visible? Packet Tracer?
Yes, sir.
Yes, sir. And please start the recording as well.
Recording is on. Don't worry
Okay,
about
okay.
recording. So let's say I have simple one switch, right? This switch. So this switch have some interfaces to connect end devices, to connect other switch, to connect router, right? To any device. For that, this switch have some ports. If you will check physical of this port, this switch, you can see there are some ports. These are port 1, 2, 3, 4, 5, 6, 7, 8 like that, like this. If you have 24 port switch, then there will be 24 ports. If you will have 48 port switch, you will have 48 ports on the switch, right? And by default, duplex configuration of all port is auto. So because of that, if you will check, so interface, let's say fast ethernet 0/1, this is one port on this switch. Fast ethernet is a type of cable, type of port. After that, ID, port ID, means in slot number 1, slot number 0, port number 1, done. And you can see here duplex is what? Full duplex. Duplex is full duplex because configured is auto. We have not connected this port to any device, so it will set their duplex to here. I think so. Run interface fast ethernet 0/0. I cannot run this command in Packet Tracer. Okay. No. So interface fast ethernet 0/1. By default mode should be full duplex, full duplex here. Here duplex should be full duplex by default, but configure is auto. If you will configure here, let's say half duplex, or you want to configure this port should work on full duplex, simply on interface you can run one command, interface fast ethernet 0/1 and then duplex. After that, question mark. So you can see we have three options. First one is we can configure auto, and this is by default. This is by default. Enable auto is by default configuration, means it will negotiate it. Let's say if you are connecting this switch to a router, if you will connect this switch to one router, here we have one router and I am going to connect this switch to this router. Once I will connect this switch to this router, and let's say on router duplex is full duplex, so automatically switch will set their duplex on this interface is full, means auto negotiate from the neighbor. Okay. So like in Packet Tracer also, you can see by default mode is half duplex here. Duplex is half duplex. So interface fast ethernet 0/1, and we have two more options, full duplex and half duplex, just to configure manually full duplex or half duplex. Okay, so you have also control as a network engineer, also you can change this value, right, if you want to change. Then here duplex is half duplex. Now I am going to, let's say, connect this switch to one router, and on router you will see by default mode is full duplex. So let me show you that switch is negotiating it or not. On router interface I need to run no shutdown command because router interface is down. And guys, there are some protocol who is responsible to exchange, this information between device need information like neighbor is using which modes. If you have configured auto, then they in the router or switches should have to knowledge about the neighbor enable. And on router you will run this command, show interface fast ethernet 0/0. Let me maximize it, and here you can see duplex is full duplex. And now I am going to check on switch. First of all, let me run here no set command, config t interface fast ethernet 0/0 no shutdown. Because of a spanning tree protocol, because of one protocol, this switch will take 30 seconds to come in forwarding state. That protocol is STP. We are going to learn this. This is heart of switching, a spanning tree protocol. Because of that, switch is taking 30 seconds. But if you want to skip this 30 seconds, here you can click, right? Okay. And now on switch, let me check the duplex. Again, I am going to run same command, show interface fast ethernet 0/1. Here now duplex is full duplex, means switch have negotiated it from router. And router is also doing same thing. Let's say here manually, if I will configure, manually configuration is auto. If manually I will configure here duplex is half, duplex half. Okay, so what will happen now? Switch will also negotiate their router will also negotiate their duplex of interface fast ethernet 0/0. So interface fast ethernet 0/1 on switch, you can see half duplex. And on router we can check, because of a spanning tree it will take 30 seconds. And now here show interface fast ethernet 0/0 on router. So now here let me check what is the duplex, full duplex. So guys, this is problem of packet tracer. Okay, it's not working fine, but on real devices you will see here router will negotiate their duplex. It will set half duplex here. Okay, this is incorrect answer, full duplex. It will negotiate from switch, because here also by default configuration is auto. By default duplex configuration on interfaces is auto. Getting my point, guys? Is it clear to all? Because of packet tracer, here you can see output is different. I have one video on it on real devices and available it on YouTube in real device configuration playlist. You can check.
Here I have one query. Hello.
Okay.
While negotiating, is there any message will be exchanged?
Yeah, electric signal will exchanged.
Actually, what are the message types?
No, I don't know that. Sorry, brother.
Can you put
You
a trace? Actually, we are getting any something on trace.
What trace?
No, if we enable the trace between the two interfaces.
How I will enable trace? Tell me.
No, in Wireshark.
No, in packet tracer we cannot capture the link.
Okay.
There are physical layer protocols. Yeah, those are signals, like signals, not messages. You know, collision network, how devices came to know that there is collision. Let's say if you have a topology like this, if you have a topology like this, switch 1, switch 2 and switch 3, these are not switch, these are hub device. In hub collision is possible, and let me show you how collision can occur in this topology hub. Okay, you are going to understand that hub always do broadcast, right? And there is chance of collision. Collision means colliding something is called collision. And domain means one collision domain means one way of communication. Two collision means two way of communication. Means there is only one way. If you will try to use as a two way, collision will occur there. This is a message. So if let's say here one computer is there, one computer is here, and one computer is here, one computer is here, one is here, let's say like this. And between hub 1 and hub 2, there is collision. There is collision. Let's say between link 1, switch hub 1 and hub 2, on this link, on collision is there, right? Means packet are colliding here. So how this hub will came to know? Because in collision domain, guys, every device have knowledge that if there is collision, then I will not send the packet. Automatically device will came to know it with the help of signal, not help the message. With the help of signal at physical layer, this computer is going to negotiate this collision here, that there is collision between hub and hub 2. So I don't need to forward the traffic for now. I should wait. When this link will free, then I will share the data. Means this PC will have information that when this link is going to free, because of signal they are going to check that link is free or not. If link is free, then only it will send the data. If link is not free, that means there is collision. So these things happening with the help of signals, right? And here also this signal is used, brother, not message. Okay, hello.
Okay.
Yeah.
Hope now it's clear to you. Yes or no?
Yes.
So
So in
device
what
sends
circumstances that collision arise?
sorry,
I mean, on what conditions that collision arise?
if
So
two
if there is
device
any-
will, let's say brother, I have one road here. On this road capacity of this road is only one car can travel on this road at a time. So what will happen if one car will travel from this side, will enter from this side, and one car will enter from this side? What will happen between it? Collision. So whenever here collision, so whenever two device connected with hub will try to send data at the same time, if this machine and this machine, both machine will send data for each other at the same time, 100% collision will occur there, because both cannot send the data at the same time, because both are connected with a single link. Inside the hub, if you will, hub is just a box. If you will open that box, you will see there is direct connection like this. Direct connection cable are there between this port and this port. There is no memory, nothing. Getting my point? So hub cannot generate any message. And this is how collision can occur if both PC will try to forward the data at the same time on this link. So this link works on half duplex. Hub works on half duplex, right? Hub works on half duplex. And if I will talk about switch, so switch works on full duplex, and router also works on
Unit.
full duplex.
Wow.
And this is the reason why we are not using hub nowadays. Why we are using switch? Because switch have
They don't
brain. In the brain they can maintain table. According to that table, they can perform unicast. Because if hub will receive one packet from this computer, it will forward this packet to all other computer as well. Because hub
Hello,
don't know how to perform unicast. It always perform broadcast only.
I'm not getting fine.
Oh my brother, mute yourself here. What the hell, yaar? Okay. Is it clear, brother? How collision can occur?
yeah.
Okay. Okay, so this is a small practical of half duplex, full duplex. You can perform this lab also in packet tracer for practice, for hand-on experience one time. After that,
So as we are using switch nowadays, so there are less chances to collision arise in switch.
no, not less. 100% collision will not arrive. Nah,
Okay.
100% collision will not have, because switch ports work on full duplex. It can do same thing, na?
Right.
Right? And there are buffer memory with all interface to control the data. Don't worry about the damage. Anything else, guys? Any other question?
Sir, initially you told Bluetooth is an example for a half duplex, right?
Yeah.
Wherein either only one party can send the message and the other party has to wait till the other will complete. But nowadays, if we have the Bluetooth headphone and all, right, we can either talk and we can also listen, right? Is it because of the version thing or how is it, sir?
That is full duplex. That Bluetooth works on full. You heard about half duplex Bluetooth? That this only sending and receiving is happening at a time.
No, haven't heard. That's why I'm asking. Like,
Oh, no. There was Bluetooth like that also. Even in my mobile also, now whatever mobile, I don't know, it is, one is Samsung and one is iPhone. Both are, when I am connecting both device through Bluetooth, so at the same time I am doing only one thing. It is not possible, right? So this is different Bluetooth. And when I am using my earpad, means that is like full duplex.
okay, sir. Okay, thank you.
Okay. Now, actual topic is today try to understand the networking devices. That first is, you already know, network interface card, right?
Question.
Yeah.
Yeah, I'm sorry to bring you back. But from what you just said, right, I want to be clear a bit. When during the connection, must the full duplex and the half duplex always match?
That is not important, brother. You can leave it, right? Because this is, no one is going to ask you these things, and you are not going to apply also in practical. So don't worry about it. Okay, forget it.
Okay,
Right? I will
okay,
tell you the important thing. What is important? Okay, don't worry.
okay, got it.
Like, this is important networking device. Okay, so try to
Okay,
understand this.
okay, got it.
Okay, great. Network interface card. Okay, you already know about the hub also. We cannot learn, right? It is better, because no one is going to use it nowadays, and no one is going to ask you about hub. By the way, hub is a networking device which is again connect multiple computer together. It is a physical layer device, right? So as I told you, that the port are directly connected with wire inside the hub. So that means it's work at physical layer, means connecting to cable directly with machine is better than hub, connecting with hub. So that's why we are saying it is a dummy device, and it works at full hub duplex. Then the new device which come in market is switch. Again, purpose is same, to connecting multiple device together. But here it learn forward the traffic on the basis of layer 2 information. It is a layer 2 device. Layer 2 device means forwarding data on the basis of layer 2 information. And layer 2 information is, as you know, MAC address. Means switch is going to forward the data on the basis of MAC address. Means switch is going to perform unicast. This is the biggest advantage of switch, over hub. Hub was doing always broadcast, and now switch is going to do unicast in the LAN. Okay, after that, switch are again used to connect multiple devices in LAN, and switch works on full duplex. Okay, means now switch can do both sending as well as receiving at the same time. Then switch can do unicast, as I told you, the biggest advantage, unicast. You will understand how switch is going to perform unicast. If anyone don't know, then it is very interesting topic. Okay, and then multicast and broadcast. So switch can do all these three things: unicast also, multicast also, and broadcast also. And then it is an intelligent device, because switch have memory. Because of switch have memory, if switch have memory, then only it can perform unicast. Means forwarding something unicastly means, I know about the source and destination. Means if switch know about the source and destination, definitely switch is maintaining some table. In that table there is information. Okay, according to that information it is taking forwarding decision. So it have brain. So that's why we are saying switch is a intelligent device. Then router is a layer 3 device, right? Again, router works at layer 3, and router works on full duplex mode. Router are used to connect two or more network together. Now can anyone tell me why we need to connect two or more network together? Any scenario where I need to connect, let's say, 10 number of routers? Do you know any scenario? Basavaraj?
While we
And
using multiple ISP, like more than one ISP, in that case, due to the failover, the ISP switches, and that's why we're using different
Yeah,
network.
great. Very good. Yes, Vasavaraj, do you want to speak?
yeah, actually, I'm also trying to say the same thing only. We have like one is active link and one is standby link. Okay.
Okay.
So in that scenario, we have to use,
Only
actually, we
two
have to
router.
maintain the two ISP link.
So two router
No,
are
we have to
required.
maintain that.
Okay. Yeah, yeah.
Yeah.
Anything else? No?
We will also use routers and WAN aggregation layer also, like especially for bigger enterprise networks where we have the DCs in different locations, Chennai, Bangalore, Hyderabad, and all, where different things are getting connected. So we usually use WAN routers also to take care of this WAN backbone connectivity using route reflector, everything.
So one router at one branch.
Yeah, usually we have two in case of redundancy.
Okay. So then again, one branch will have two router only. Why we need to connect 10 number of router, let's say, together?
It's like acts like an internet, right? Maybe I don't know.
If we have a different branches also, in that scenario, we have to connect a number of routers, right?
Where? On every branches, right? One router on
Yes.
every branches, or maybe two router, one for redundancy.
Yes.
And
Yes.
your router is connected to ISP router. One more router is there, and ISP router is connected with, let's say, other branch office. So four or five routers are there only.
Yeah, based on that, our requirement only, we need to connect that routers. Okay. Whether it is a 10 routers or two routers or four routers, whatever it is.
Yeah, exactly.
It has multiple benefits like cost saving, if we use the switch, so we need to have 10 switches for to connect this 10 network. In the case of router, we can we use one single router to connect these 10 networks. This is one advantage. And security purpose also we can use. So multiple things are there actually.
Yeah. Exactly.
No, we can still use VRF also, right, to make one physical router to act as a two virtual
Yeah,
routers.
yeah. Two router, four router, like this, na? Yeah, dividing, that is dividing routing table is called VRF. So we will understand it, don't worry. Okay, for now, okay, router works at layer 3. It works on full duplex and it is used to connect multiple network together. Then there is some introduction about collision domain and broadcast domain. So here also you can read collision domain. Collision domain is a domain where collision can be occur. A domain where collision can be, if someone will ask you, you will have this language to remember. And a collision occur when device two devices send a packet at same time on shared network segment. Shared network segment. Hub having one collision domain means one guy can send and all other can receive the data. receive only. Let's say you have connected 10 computer together through one hub. So if one computer is sending the data, you all have to wait. Okay, and this is one protocol, CSMACD, which is used to detect the collision, right? This protocol generate that signal. As I told you, signal will generate and it will negotiate the duplex. CSMACD is going to detect the collision. CSMS, yeah,
Currently, we're not using this one, right?
yeah. It stands for what, guys? Anyone?
Circuit switch multiple access.
Collision detection.
Yes.
Detection, yes.
Yes. So it is used to detect the collision. And switch and router have per port collision domain. See, router have per port collision domain means a router have two interface, means they have two way of communication. From one side they can perform both sending receiving, from other side also it can perform both. So it have per port collision domain, and switch have one collision domain. This is problem. Or per port collision domain, per port collision. Switch have also per port collision domain, means there is no chance of collision in case of routers and switches. Both have per port collision domain. Both have one way of communication, separate way of communication, right? And broadcast domain, again domain where broadcast message can be travel. Broadcast means one, and one to all, and domain means area. Okay, this is language. Okay, broadcast domain means domain where broadcast message can be travel. And all ports of switch and hub are in one broadcast domain. Still switch have one problem, that their all interfaces belongs to one broadcast domain. So we have solution, right? Later VLAN, or we have a solution, lots of solution are there, but by default all ports of switch belongs to single broadcast domain. Means if let's say there are 10 computer connected like this, okay, we'll explain later, that is also fine. Switch and computer A, B, C, let's say D, E, F, lots of computers are there. If computer A need to talk with computer B, right, and computer A need what, MAC address of computer B first, so it will generate one broadcast message. So that broadcast message will receive by these all computer, because all ports of switch belongs to a single broadcast domain. So this is one broadcast domain. And router have per port broadcast domain as well as per port collision domain. Okay, so again we have problem. If here we have router R1, and this router is connected with again one switch, and this switch is connected with some users, right? Here now if user from this network want to reach in this network, what will happen, guys? Can anyone tell me the process?
What is the question?
This user want to communicate with this user. Let's say source MAC is A, destination MAC is, let me change the pen color. Source MAC address is A, source B, so destination MAC address is, let's say, B, source IP address is 10.1.1.1, and destination IP 10.1.1.2, sorry, 20.1.1.2, different network. 20.1.1.1. If these two devices want to communicate with each other, how these devices are going to go? First of all, tell me how this machine, center machine, will resolve MAC address of this destination. This time destination is, this machine will look up for the MAC address of this IP address 10.1.1.20.1.1.1. Yes or no?
Oh, yeah.
So it will generate broadcast message.
Yeah, and then it will reserve the MAC address for gateway first.
No, it will generate the broadcast message and it will forward to gateway.
Yeah.
In the broadcast message, in the ARP message, what will be the source? 10.1.1.1,
1.1.
destination,
20.1.1.1.
source MAC,
Source MAC will be A and destination MAC will be 12 times F.
F. Very good. Now router will receive this information on this interface. See, this is in different broadcast domain. This is in different broadcast domain. Router cannot forward broadcast message at layer 2 from one domain to another domain. This router cannot pass this broadcast message. Router will simply drop it. Router will drop it here. Then how this machine will resolve MAC address of this IP address?
By routing.
By routing, here routing is not required.
No, actually, router will add this information in the ARP table, and router
Actually,
will
actually
give the
this sender machine will check first the destination is what 20.1.1.1. If 20.1.1.1 belongs to my network, then fine, I will generate ARP. If destination IP node belongs to my network, then my responsibility is just to transfer the data to default gateway. Now it's headache of default gateway, how default gateway is going to treat it.
yeah, in the
So
ARP table.
destination MAC will be always the MAC address of router interface.
Yes,
Then
correct.
again, router will not forward the broadcast message at layer 2. At layer 2 also, destination MAC will be the MAC address of default gateway. At destination MAC address. When this PC will generate ARP message, it will generate for their default gateway, not for 20.1.1.1, and their default gateway will respond. They will send their own MAC address instead of MAC address of 20.1.1.1, and it have make entry in ARP table. According to that entry, now if this machine need to send ICMP packet, so it will encapsulate ICMP packet. After that, it will hand over to IP. IP will add this source IP address, this destination IP address, and then one type field, and it will hand over to lower layer, means data link layer. Data link layer will add source MAC and destination MAC. Destination MAC will be the MAC address of default gateway, not this destination IP address, not 20.1.1.1. Okay, you will see, lots of time this in practical.
Means here you are sharing that router will be act as a gateway.
Right, this router is gateway. Gateway means what, guys? Gateway means exit point, means gateway. That is the last point. So like this PC, at layer 2, this PC responsibility is whenever this PC want to send data in outside, in other network, then their responsibility is at layer 2, they need to forward it to default gateway, to their default gateway. That is router interface. Okay, so this is about router. Then broadcast domain, and after that next topic is very interesting, how switch will learn MAC address table, how switch will learn MAC address. So now guys, anyone will explain this
Sorry,
process
hello,
in this
sorry for the
topology?
interruption. G.
Okay.
If suppose in that router we have configured that both network like 10.1.1.0 and
Okay.
20.1.1.0, actually this time it should be forward, right?
0 is network ID first of all. 1 or 2 should be the IP address, na?
Okay.
In this topology, can you explain how switch is going to learn MAC address of PC1, 2 and 3? All MAC addresses, you can see PC1 is using MAC address A, PC2 is using MAC address, PC3 is using MAC address C, and PC2 is using MAC address B. One function of switch is learning MAC address. One of the function. ARP table? No,
MAC
not
table.
ARP table. MAC address table.
Yes, MAC table.
MAC table, or you can say CAM table,
The packet, it will
content.
receive by the switch, and switch will maintain the
Not
details.
packet. Switch will receive frame always, not packet. Always keep in mind this also.
Yes. Switch will receive this frame, and it will look up the source MAC address. So, and then it will add into the Mac table by according to the port number,
Okay, let's say
then it,
this is 0/1, this is 0/2, this is 0/3, right? So when switch will receive data or frame from PC1 on this interface 0/1, it will learn one MAC address. 0/1 MAC address is A. Like this?
yeah, and it will add this type also and VLAN number that is also there. So that
Okay, we will talk about that later. Leave. This is
yeah,
correct?
yeah, that is fine. And then it will look up the it will entries is added, and then it will look up the destination MAC address.
So destination MAC address is B.
So B, it will check in the MAC table. It entries are available. And then associated with the port number, it will send to that respective port number. If entries are not available, then it will do the broadcast. So that is called
Okay, it will forward one copy to this PC also and one copy to this PC, right?
yes, correct.
Then
And then suppose it is belong to the you said B, right? Then B will receive by because in the destination MAC
B
it
will
is
generate reply, right? B will
Yes,
generate
yes.
reply.
It will
and then
learn
again
that.
receive this packet, and then again it will learn the MAC addresses of B
First
by
it will learn the MAC address 0/3 MAC address is B. First it
yeah,
will learn source.
yeah. So
Okay,
now which has the details about this
one
PC1.
second. Yeah,
So now switch will receive these B packets, and then it
it will
will
again
have
compare
yeah.
this
So
table.
MAC table, and then it is this packet need like this frame need to send to the PC1, and it will say it will check the MAC table. The port number is 1 by 0 by 1, so it will send to the 0 by 1.
Yeah, when switch will receive reply packet, it will check the destination. Destination is A in the packet in the frame. It will check their MAC address table for A destination. Exit port number is 0/1. It will exit the frame from this interface, and this is how PC1 will get reply message. So first message was broadcast. Because why switch did broadcast that time? Because switch don't know, the switch don't have any entry in their MAC address table for that destination, for destination B. So whenever switch will not found any entry in their MAC address table, then also switch will do broadcast. This is one behavior of switch. Okay, and this is nothing but a non-unicast flooding. What we called it, a non-unicast flooding. It is a non-unicast, means unicast a non-flooding, right? Unicast a non-flooding, a non-unicast flooding. Okay, this is called a non-unicast flooding. And broadcast, when switch will, sometime interviewer can ask you like this: when switch will perform broadcast and when switch will perform a non-unicast flooding? How you will explain?
Yeah, in the entries, it will have the source and the source MAC and destination MAC, respective source MAC and destination MAC. That time, and then it switch will check the these details. If it is available, then it directly send the unicast. And if it is the entries are already mentioned, but it is not available in the switch, I mean MAC table, then it will do the unicast. Sorry, unknown unicast.
No, this time what I am saying, that switch is receiving a frame, in the frame destination is broadcast.
That time
Then switch will do what?
it will do the broadcast.
And when switch don't have entry in their MAC address table, then switch will do what?
Broadcast only.
That is also broadcast, but that
Yes.
is called a non-unicast flooding. A non-unicast flooding. Okay. Whenever switch will not have information about the destination of unicast message, it have to perform broadcast. Okay.
Yeah, here actually, Jay, I have one doubt. In that broadcast message, na? So it
Okay.
will learn that all that port's MAC address or only that particular destination MAC address? How it is?
Particular destination, na brother. Switch have not learned any MAC address on this port. You can see, because switch will learn MAC address on this port when switch will receive any frame over here. Until and unless switch will not receive any frame over here, it is not going to learn any MAC address, because this is behavior of switch. Whenever switch will receive frame, first of all it will learn source MAC address. After that, according to destination MAC address, it will take forwarding decision that from which interface I need to exit. This is very simple, brother. No, it's complicated.
No. It's not complicated. But it's broadcasting only FFFF only, right? That
In
broadcasting
two
is
scenario, it will perform broadcast. One is when destination is all FFFF, and one is if entry is not available.
okay. In the first scenario, okay, if there is no entry in MAC address, it will send that broadcast message, right?
Yeah.
So in that time, my question is, in that time, it will learn that all the ports MAC address or only that particular.
Why it will learn the all port MAC address? Because it will receive any packet. Why frame? No. Because all PCs, all REST PCs are going to drop the packet, drop the frame, yeah, for
Okay.
their packet or whatever things you can say data, they will drop it. So until a single thing I am saying that until and unless switch will not receive any frame over here, it will not learn MAC address. Why? Don't know. You are asking same question.
No, it's just for the clarification. Okay, thank you. Yeah, I got your point. Okay. Yeah.
Okay.
So what's the terminology name you told, sir? When the switch receives the purposeful broadcasting, what is the terminology called?
Unknown unicast flooding.
Unknown
Flooding means yes, unknown unicast flooding means unicast is unknown, because of that switch is performing flooding. Flooding means broadcast. But it will learn MAC address of only that device which belongs to destination.
Okay, I mean that's what I just wanted. I didn't get those two terminologies. One is unknown unicast flooding, and the other one is
Other one is broadcast.
okay, normal BC. Okay, sir. Thank you.
So there is some difference between unknown unicast flooding and broadcast. Yes or no? When switch will receive a frame where destination is all F, it will perform broadcast without checking any table. Why, right? It will forward one copy from all their interface except receiving interface. Okay. It will forward one copy from their all interface except receiving interface when destination will be all F. And second scenario can be switch have received a frame where source is, let's say, A and destination is B. When switch have checked their table, in their table there is no entry available for destination MAC. Means switch don't know what is the exit interface for this frame. So let me forward this frame to all other computers. This is simple statement. Huh? What happened, guys? Tell me. Still doubt? Is it clear how switch is going to forward learn the MAC address table? Somnath, are you there?
Yes, sir.
Yeah, tell me. Is it clear?
Yeah, no problem, sir. I think you have taken this before also.
Yeah. Now, how we can identify the devices? You already know there are two types of address: MAC address and IP address. Then we discuss IP addressing these things. Okay. After that, there is some introduction about router. Like router is used to connect multiple network. Router works at full duplex. Router has per port broadcast domain and per port collision domain. This is only important, right? Means if switch have 5 port, that means 5 ports have one separate broadcast domain, right? But one domain of broadcast message cannot enter in another broadcast domain. Okay. So router maintain routing table where they kept best path to reach from one network to another network. Okay. So yes, definitely router is used to connect to two or more network together, and router maintain routing table, right? In the routing table they will put only best path only. Maybe routing table will have 1000 number of routes and you are able to see only, let's say, 500 number of prefixes in their routing table.
So, Praful, can you explain that per port broadcast domain and per port collision domain?
Purport, okay, let me ask you one question here. Let's say here I have one router R1, R2, switch 1 and hub 1. This is hub. Here I have one PC. Here I have one PC. Here I have one PC. And here I have one PC. This is connected like this, like this, like this. Can anyone tell me how many broadcast domain are there and how many collision domain are there? How many broadcast domain are there and how many collision domain are there? Guys,
Three-
router have
three
per
broadcast
port. Yes, 3 broadcast.
and collision means
How three?
five collision.
5 collision. 1, 2, 3, 4, 5. Sure.
1, 2, 3, 4.
Okay.
Yes, 5. Yes.
Okay. Is it clear to all? See how we are counting broadcast domain and collision domain. As I told you, all ports of switch belongs to single broadcast domain. Means these port are in single broadcast domain, and router have also per port broadcast domain. Means this port of router and this port both are in single broadcast domain, and this two port is also member of same broadcast domain. Means this is single broadcast domain. This is one broadcast domain. And after that, as you know, switch means router have per port broadcast domain, means this port will also have one broadcast domain, and this router will also have one broadcast domain, and these two are directly connected with each other, same broadcast domain. Both are belongs to same broadcast domain. Both router have one separate broadcast domain, right? And this is one other broadcast domain. So broadcast 1, broadcast 2, and broadcast 3. Broadcast 3 broadcast domain. After that, as you know, switch has per port collision domain, means this is one collision domain, this is another collision domain 2, this is also one collision domain between router and switch, right? Both have per port collision domain, so both belongs to single collision domain. 1, 2, 3, 4, and 4 is here also we have one collision domain, and fifth one is hub have one collision domain, means all port of hub belongs to single collision domain, means there is only one collision, right? This port and this port belongs to same collision domain, and other ports are belongs to same collision domain, means how many collision domain are there? 1, 2, 3, 4, 5. 5 collision domains are there. Okay, now 1 minute, guys. I have one router here, I have another router, and I have some switch. Then we have some hub, and then we have some computers and user devices. These are computer. Okay, now let me connect these devices. Okay, so see here, this is router 1, switch 1, let's say switch 2, this is hub 1, okay. Now can anyone tell me how many broadcast domain or collision domain are there?
6 collision domain, 3 broadcast domain.
Okay. Yeah, who have dot, guys? Come. I got my pen. Yeah, router has purport broadcast domain or purport collision domain or purport broadcast domain, or all ports are single broadcast domain and collision domain. Router had purport broadcast domain, right? Okay, first of all, tell me, hub have purport broadcast domain and or purport collision domain, and both means broadcast. Hub have purport broadcast domain or purport collision domain, or all ports of hub belongs to single broadcast domain and single collision domain.
All
Yes,
ports belong to.
single collision domain and single broadcast domain.
Single broadcast domain, single collision domain means all ports of hub belongs to single broadcast domain as well as single collision domain. Means this port, this port, this port, all ports are in same broadcast domain and same collision domain. That means these devices are in one broadcast domain and one collision domain. After that, here switch have also one broadcast domain, and this broadcast domain of switch is connected with this port. So this port and this port now in same broadcast domain because both are all port in broadcast domain, right? So this broadcast domain is still here. And collision domain, again collision domain also, switch have also one collision domain, per port collision domain means this port is in one collision domain and this port is connected with one port, their collision is again one. So both interface will become the part of same collision domain. Same collision, part of same collision domain. And after that, this port of switch also connect with same switch. This port is also connected with same switch, and as you know, both port belongs to same broadcast domain means this is also come under broadcast domain, single broadcast domain. But between this port and this port, is there any collision domain, guys? Two collision domain, because both have separate collision domain, right? So this port and this port belongs to one collision domain, and this port, let me change the color, this port and this port, one collision domain, and now this port is in different collision domain, right? Because per port switch has per port collision domain and single broadcast domain. So you can see though both ports are in single broadcast domain but in different collision domain. Again, this port of this router belongs to same broadcast domain, single broadcast domain means this entire domain is a single broadcast domain, and both interface have one separate collision domain per port collision domain. So these two ports belongs to single collision domain. So till here, how many broadcast domain and collision domain are there? Only one broadcast domain, because this broadcast domain also extended over here, right? In the same way, between router 1 and router 2, both have one broadcast domain and one collision domain, per port broadcast domain, per port collision domain means one broadcast domain and one collision domain here, and here one broadcast domain and how many collision domain? Two collision domain are there. One broadcast, two collision. And again, these all devices connected with router is belongs to single broadcast domain means this is a single broadcast domain, but switch has per port collision domain. So this port and this port are in different collision domain, this port are in different collision domain, and this port are in single collision domain, right? Hub is also part of that collision domain because all ports of hub belongs to single collision domain. Okay, so how many collision domain we have here? Broadcast domain is one broadcast domain, and 1, 2, 3 collision domain. Now you can add. Is your answer matching, brother?
There should be two broadcast domain,
Where?
router 1 and router 2.
This is one broadcast domain, this is one broadcast domain, this is another broadcast domain, and this is another broadcast domain. Three broadcast domain are there.
Right side, what are the collision domain? How many collision domain you have written? 2 or 3?
One here, and one here. Yes, 3.
Yeah, then 6 it is, right? So then my answer is matching.
Yeah. Okay. Understood, everyone? How we are calculating broadcast domain and collision domain? After that, yesterday we discussed about the memory of router as well. Like router have RAM, and RAM is a random access memory. It is an volatile in nature. When power goes off, okay, device content will lose, like ROM, NVRAM, flash, and then content in memory of router, like RAM carry, running configuration, ARP table, again routing table, ARP table, running configuration, and interface buffer memory. Right? RAM store these information. ROM store mini IOS, post mini IOS, boot startup, program, and etc. Then NVRAM. NVRAM store startup configuration means save configuration and configuration register value. And flash store main IOS image. Then booting behavior, we already discussed this. Then mode of router, as you know, user mode, privilege mode or enable mode, then global mode, global configure mode, then interface mode, and then Roman mode. Okay, we have some information about mode as well in different PDF. In this PDF, here you can, if you want to learn more about, with the mode, here is, I think, some introduction with each mode. Like user mode, this is a user mode. It allow you to view the state of router, but will not allow you to modify its configuration. Okay, then enable, by pressing the enable command you can enter in privilege mode. By using disable command, again you can enter in user mode. After that, command to move in global config mode. Then basic configuration on router, like, okay, then here you can see the command, some command, basic command, like command to configure banner on router, on a router.
Sir, this PDF can you please share?
Yeah, okay, I will see here. Okay, so if you want to, apply some banner on router, you have option. Like when I will access this router, you can see here, now I am accessing this router. After booting, it will not show me any message here. So if you want to put message to the user, to the people who will access this router, some message, then you can use this feature. Right here you will get the message. Command is very simple. Yes, can anyone tell me the command? Banner motd, and then, okay, after that enter the message, what message you want to set. So let's say this is CCNA class, and after that with same character you will terminate the connection. So hatch was that. So now I have got again access in privilege mode. And now if I will exit from here, so you can see next time I am getting one message, this is CCNA class. Okay, so like this you can configure banner as well. Sometime we provide username and password. Maybe then why, don't know why people have configured then. because without getting access, you can see I don't have access. This is in user mode. Here I can only check view command, some view command only, like this command only, right? But to enter in next state, I need password, enable password. Okay, this is how we can set banner. And after that, Here is also command. You can see that you can write down the command. And then how to save the configuration. Command is very simple to save the configuration. Copy running configuration to a startup configuration. Then it will ask for destination file name, so you can leave it for default as well, and you can configure it by your choice. After that you will get this message and okay.
You can use write also.
Right also. What? Sorry.
Write memory. Write memory. We can use the alternate command for that. Copy running config.
Right. Exactly. We can use write command as well, guys. This is one command to copy running configuration. This is actual method for learning, and for practical you can directly use write command, right, to save the configuration. Let's say on this router I am going to configure something like host name R1, and I will save the configuration. So I can use this command, write command, or I can use copy startup. So copy running configuration to startup configuration, running configuration to startup configuration, like this. After that, again copy a startup configuration to running configuration. Also, this is also a command, startup to running. Let's say you have something in a startup configuration and you want to copy it in running, right? So you can copy it like this. Okay, so yes, we have two commands here to save the configuration. Then enable password. You already know how to enable. The enable password command is very simple. Yesterday also we use it. After that, enable secret command. Okay, then some verification command at basic level like show running configuration. We can use this command to check running configuration of router, right? After that, host name we can see there. Get enable password. These information, these are few output of this command. Okay, then configure console password. How to configure password on console port. Now I think there is security part. So line console 0, password is this one, and then login, whatever password you want to set. So these are three commands to configure password on console port. After that, here you can see what is the configuration. Configure IP address on router. Okay, no problem. Then configure NAT on router. How to enable NAT. So this is command to enable NAT. Guys, you need to perform at least this lab once. Okay, because we are not going to perform any basic lab in upcoming day. We will discuss only advanced thing. Okay, so please perform basic lab also, so that we can clearly understand advanced lab. Telnet. And then
hello.
yeah,
While configuring this telnet, actually we are using that line VTY 04.
yeah.
Actually, what is the meaning of that 04? 0 space 4?
0 space 4 means 5 user can access this device at a time. 0 to 4 user. 0 to 15 means 16. Maximum number is 16. Okay.
0 to 4 means
0 to
okay, 5 users, right?
Yeah, 0, 1, 2, 3, 4.
Okay.
There are 4 virtual line. Means 4 user can access this router at a time through remotely.
Yeah.
Getting my point?
Okay.
Okay. Then again command to configure SSH. So guys, SSH configuration is difficult as compared to telnet. So here you have command. You can at least run this command on router. Okay. After that, command to configure telnet on layer 2 device. So on layer 2 device we don't configure any IP address because it is layer 2 device. It is used to forward layer 2 information. So on these switches we have one interface, that is virtual interface, that is called VLAN interface. That VLAN interface is used for management purpose of this switch, just like to take remote access of it. We need IP address. Without IP address we cannot access any device. So on layer 2 switch you will have one virtual interface. On that virtual interface you can configure the telnet, and here is the command how you can use the process. Like process is, I think 2 to 3 command are extra. Okay, here first I have configured IP address on virtual interface virtual 1. Then I have run nosert command there, and then I have configured this IP address 10.0.0.1 to 5.0.0.0 exit. Then line VTY 04 means give the access to 5 user, password Cisco 123, and then login. there is one more option, login local. Can anyone explain what is the difference between login and login local? Here you will have one more option. When you will log in, you will have two options, login local or login only. Let me show you also here.
I think login means it will save in the database.
No, line VTY 04, and I'm going to say login, and you can see put the question mark. Login local option is there here. Authentication, we should have one more. Local login or login local only option. So maybe on packet tracer we cannot run the command. Okay, I will show you on GNS3, don't worry. There will be two command, login and login local. So login means if you are running login command only, it will ask for username. Means the people who want to access the device, they need only username. That's it. Sorry, password. Only password. If they know the password, they can access the router. Sorry, extremely sorry. Password. And login local means it will ask for both username as well as password. So here we can perform the practical of this, but on packet tracer I think we are not able to run the command. So don't worry, tomorrow or maybe when we will access the GNS3, I will show you this configuration. We will have two options here. Okay. Then if you don't have budget to configure to purchase DHCP server, so you can configure DHCP service on your router as well. So these are the command to configure DHCP on router. These are the command to configure DHCP on routers. On router also we can enable DHCP. Like on this router, let's say I want to enable DHCP. So what I can do, IP. What is the command? Can anyone tell me the command?
IP DHCP.
How to IP DHCP pool, and then
pool name.
Whatever name you want to define. Pool name is, let's say, CCNA.
CCNA.
Then
enter.
Okay.
Then
IP?
network IP runs.
Network. Which network? Any network. Let's
Whatever
say 10.0.0.0. Subnet mask is, let's say, 255.255.255.0. Okay. Then router ID.
Yeah, default gateway.
Default gateway. Default router. Let's say 10.0.0.100. Fine. Now DHCP service is enabled on this router. Anyone can get IP address from this router. Now this router is acting as a DHCP server as well. Okay. So you guys can perform the lab if you want to perform. These are the command on router. You can configure it. And then to get IP address from PC, we can run this command, IP address and then DHCP. Only this command I need to write. Like on router, if I will try to run one command, interface fast ethernet 0/0. See, we are getting two options, IP address. After that IP address you can configure here, or you can say DHCP. So now it will get IP address from DHCP. So this interface get IP address. So IP interface brief fast ethernet 0/0. Port is shut down. Will this port get IP address from DHCP server?
Show interface status.
This interface should get IP address from DHCP server.
Can you repeat the
So
question once again?
Yeah, it's DHCP.
yeah. Interface. This command is not here, right? In packet tracer. We'll perform one lab of these things, on GNS as well.
Actually, Prabhu,
Packet tracer is mainly for switching.
Okay. One question,
Yeah.
Prabhu. Actually,
Okay.
we are using different network in same, right? Actually, we are using LAN side 10 series and 20 series network. If we are configuring DHCP in router, we have to add one more network, right? Network, we rightly we add a network 10.0.0.0 like that. Then if we need to add for DHCP for 20
Yeah.
network, then we need to one more network we need to add, right?
Exactly.
Yeah.
Fast Ethernet 0/0 should have
Because I
IP
have
address.
no hands-on experience on that because we have DHCP server. That's yeah, all right.
And when you will configure DHCP belongs to different network, then you have to add one extra command as well, IP helper address.
Yeah, right. Yeah, right.
Because router cannot to broadcast. So we will
Yeah.
perform one lab actually. I have leave here, because so run interface and the interface ID command is very good command, right? To check the basic information.
Yes.
But here I am not able to run that command. So that's why, okay, I will perform this lab on GNS3. Tomorrow maybe we will take one more day for basic module, then we will start routing. Okay, like this you can configure DHCP in packet tracer also. There is a screenshot of packet tracer to follow the step. Then configuring DHCP relay agent. When DHCP server belongs to different network. When DHCP server belongs to different network, then what will happen? See, this client will generate DHCP message. This client will generate DHCP message and it will DHCP message broadcast. Let me tell you something about DHCP first. Guys, DHCP work on DORA process. DORA process. Okay. So DORA stands for discover, offer, request, and acknowledgement. Means these are four messages of DHCP. D is used by sender. After that, O is used by server, means DHCP server. R will send by client machine, again sender, and acknowledgement will send by DHCP server. In discover message, if I will talk about discover message, so see, this client don't have any IP address. So this client don't know what is source IP address. Yes, client don't know about the source IP address because client don't have IP address here. So what client will do? Client will generate one DHCP discover message. In that discover message, they will mention source IP 0.0.0. 0.0.0.0. That source IP is 0.0.0 and destination IP is I don't know who is DHCP server, right? This machine don't have any 255.255.255 discover message. At layer 2, at the same time, at layer 2, what will be the source? 0.0.0 or source MAC address of client A. MAC address of client A. Okay, and destination MAC will be all F. When router will receive this broadcast message, router should drop it. But guys, there is some, first of all, router will check what source MAC and destination MAC. So if destination MAC of router is the MAC address of the router is receiver MAC, then only router will receive. Otherwise, it will drop it. After that, when it will came to know that this is a broadcast message at layer 2, so it can be for me also. So okay, fine, let me check layer 3 information. Router will check layer 3 information. Layer 3 information is what? Broadcast. Router cannot forward broadcast message. Router should drop it. But here we will configure something. After that, router will forward that broadcast message as a unicast message to this server. As a unicast, server will receive the message and it will forward as a unicast to server. That means we need to tell to router who is DHCP server. Router is going to treat DHCP discover message as a broadcast message, but it is going to send their own message to server as a unicast. Okay, so router is actually not forwarding the broadcast message, it is forwarding one unicast message. It will deliver the discover message to this server, and then when server will generate offer message, again offer message. See, this machine still don't have IP address, right? So destination IP will be again broadcast 255.255.255.255, but source IP address and source MAC will be the MAC address of this server, right? This server. So what PC1 will know? PC means router 1 will know the MAC address of this server. It will whatever entry they need to update, they will update their entry. After that, it will forward to. Can anyone explain the process, guys, from here? Dora, discover, offer, request, and acknowledgement. First, this machine have sent one discover message that is broadcast at layer 2 also and at layer 3 also. In discover message, source IP address will be 0.0.0, right? And router will forward that broadcast message as a unicast address to DHCP server, and now router is responsible to provide IP address from DHCP, means router is going to communicate to DHCP server, right? And then this server and this client will exchange 4 messages: discover, offer. Why discover message? Discover message to discover DHCP server. Who is DHCP server, right? So by sending a broadcast message, and in next message it have found their MAC address, sender MAC address, right? So discover message was absolutely for discover the DHCP server. Then it will send, and in the DHCP server will send offer message. When DHCP server will receive discover message, it will came to know that someone is requesting for an IP address. So let me generate one offer message. In offer message, they will send one IP address, right? And again, this machine don't have IP address, so it will generate broadcast message, right? So all message you can see: discover message, offer message, at request message, and acknowledgement message. All messages are broadcast. But at layer 2, only discover message and offer message are broadcast. Only discover and offer are broadcast, because next time switch, means this PC will have information about the MAC address, means router will have the information about the MAC address. So entry is updated. So like this, we will see how we can configure DHCP relay agent on router if DHCP belongs to different network. If DHCP belongs to same network, then process is very simple. Client will send discover message, right? Broadcast it. This machine will send offer message, right? This machine will send one request message for that IP address. Can I assign this IP address, right? Like duplicacy, and then server will again generate acknowledgement message that yes, you can assign the IP address. Now this PC will assign IP address, their interface. When it is in different network, first of all we need to configure router to helper address, who is going to help to the router to forward this DHCP broadcast message to this server. Okay, so that's why here you can see in the command also I have added this command, IP helper address, and then IP address of server. This is IP address of server. Okay, so you can also perform this lab. This lab is possible in packet tracer. Yeah.
Hello. Do we have this DHCP server configuration, FTP configuration, or DNS configuration? These labs, these sessions we have, right, in the coming days?
Lab?
Yeah, I mean sessions we have, right? How to configure the DHCP, DNS, FTP?
Yeah. One day is there, yes, for configuration in GNS3.
Okay.
Yeah.
Actually,
but it is very basic. You can also configure by yourself if you want to, save the class so that we can.
No, Professor. Actually, what happened is in GNS3 we are not able to see the routers, or the
routers.
Routers are those
in your GNS3.
Yeah.
Okay. You can give me the.
Yeah. We'll discuss this.
Till here, okay?
Yeah.
Clear?
Okay, sir. This is okay. I was trying to use this because Wireshark is not accessible in packet tracer. No, so GNS3 I tried.
No, GNS. So that's why I will also configure relay agent or DHCP configuration on router on directly, packet tracer, so that I can show you the capturing.
Okay.
Discover how discover message look. Discover LoRa process in DORA process we have 4 messages: discover, offer, request, and acknowledgement. Some messages are broadcast in operating system at layer 2. At layer 3 all messages are broadcast, but at layer 2 some are broadcast and some are unicast. In Windows operating system, in Cisco IS all are broadcast. All are broadcast. Okay, so I will show you in GNS3. We will do one thing. We will take lab of 2 routers. On one router we will configure DHCP service, and from the client side we will capture the link, and then we will request for IP address. Is it fine?
Yeah, yes, sir. Makes sense.
Then okay, see here we have now a static routing configuration. So we are soon going to start this configuration as well. For now I am closing this PDF. You have already this PDF, right? Or I need to
No,
share
no,
it?
you need to share it, sir. We don't have.
Configuration one, right?
True, true.
And G, you can share that subnetting PPT, that questions. I think I didn't
Submitting
found.
Q&A. I have shared. I think submitting Q&A.
Yes.
I have already shared. Yeah. I have shared it. Now guys, any doubt?